Okay, so today we're going to talk about law of sines, law of cosines, like how to decide when to use which one, and about some area formulas. So to start with, this is starting with number 5 because it continues in the law of cosines section, so section 6.2, so you can just pick up where you left off with your notes for Friday. And then I'm going to backtrack because I don't think in my video for law of sines I did a very good job of, I explained it, but I think I did a better job of showing it and having something for you to write down when I did it in class. So in the law of sines notes, before we put in the case 1, case 2 stuff, I did a brief little discussion in class where they wrote this information down. So if you're given angle, angle, side, there's only one possible triangle that could be made out of that. And you're going to use law of sines to solve because you have a matching pair. You have an angle and the side opposite. Angle, side, angle is going to be the same way. There's only one possible triangle, and you're going to use the law of sines because you have a matching pair. If I have side, angle, side, that also only forms one triangle, and we have to use law of cosines because there isn't a matching pair. So right here, you don't actually have a matching pair, but as soon as you find this angle, you'll have a matching pair. And you can do that without using any trick. You just subtract from 180. So if you have two angles and a matching pair, then you're going to be able to use law of sines. If you have one angle without a matching pair, it's law of cosines. If you have one angle with a matching pair, that was the ambiguous case, and you'll use the law of sines, but you've got to figure out how many triangles you have. And if I give you 3 sides, that's law of cosines. So this is just a little way of summarizing when to use what and how many triangles you're going to have in different cases. So it's always one triangle unless you have this ambiguous case. Okay, so make sure you have that written down, pause the video, and copy it in your composition book if you need to. And then we have what we're going to do today, which is just, can we look at what we're given and say how many triangles, not how many triangles, whether we're going to use law of sines or law of cosines. And then we'll do a couple of problems. Okay, so if we look here, you have an angle, only one, and no matching side. So this would be law of cosines. All right, the next one, you have 2 angles. They don't give you the matching, but you can find angle C easily and have a matching pair, so law of sines. 30 sides is always law of cosines. And then here you have one angle, but you have the matching pair, so it's ambiguous, but you'll be able to use law of sines to solve that. All right, so now let's work on, can we solve some triangles and make a decision about what to use first. All right, so like always, we're going to set up what it is we know and we're looking for, which is also going to help make the decision for you about what you're going to use. All right, so if we look at this, we have no matching pair, which is obvious when you set it up like this. And there's no easy way to find a matching pair because you're not going to be able to find A or B with subtraction. So we have to do law of sines, law of cosines, and law of cosines is what you use when you don't have a matching pair. So we're going to start with the law of cosines. So we'll use the law of cosines to find the side C. So we can say C is equal to, C squared, is equal to 10 squared plus 12 squared minus 2 times 10 times 12 cosine 70. And then we can just say C is equal to the square root of that. So typing that in my calculator, I get the square root of 10 squared plus 12 squared minus 2 times 10 times 12 cosine 70. And I get 12.7. All right, right, so then we can set up the law of sines using C as our matching pair. And we can find this is going to be our biggest angle, so it doesn't matter which one we find, but I'll go ahead and find A. So we can say that angle A is equal to inverse sine, because we're looking for an angle, and then we cross multiply and divide. So we get 47.7. And then to find angle B, we can do 180 minus 70 minus 47.7. So that's 62.3. All right, try another one. All right, for number 10, which you can't see, there you go. For number 10, we are looking, we have two angles, so we know we can use law of sines first. So setting up that we know A, but not angle A. We don't know side B, but we know angle B. We don't know side C, but we do know angle C. Alright, so this one is no matching pair, but you have two angles, so you can figure out angle A. Which is going to be a pretty big angle, 161. Alright, so now you have a matching pair, so you can use law of sines. And let's see, we'll find side B. So side B will be equal to 160 sine 12 over sine of 161. We get 102.2. All right, and then we have to use law of sines again. To find side C. So remember we cross multiply, divide, so we have 160 sine 7 divided by sine of 161. So this times this, because they're diagonal, divided by the other one. And it's going to be the same thing I just did, except for this 12 is going to be a 7. So we get 59.9. All right, number 11. They give us three sides, which means we're going to have law of cosines, and then we run triangle. All right, so we know A. I'm going to see if I can set this up where I just do this. Maybe I can write that small. Apparently I can't. Okay, so if we have three sides, then we're going to use law of cosines. And sorry y'all if you can hear that clicking. I'm trying to get more lead to come out of my pencil, but it's not happening. I was push pencil. Alright, so remember we said we want to find the biggest angle first, and then that way we know we've gotten that obtuse angle out of the way if there is one. So 13 is the biggest side. So we're going to say 13 squared is equal to 11 squared plus 7 squared minus 2 times 11 times 7 cosine. This was side B, so of angle B. All right, when you're solving for an angle, you have to do a little bit of cleanup. So 13 squared is 169. 11 squared plus 7 squared is 170. And 2 times 11 times 7 is 154. All right, so then we're going to subtract 170. And what is that, negative 1? Divide by negative 154. So we know that angle B is the inverse cosine of 1 over 154. So second cosine 1 divided by 154 on my calculator. And I get that angle B is 89.6 degrees. If you need to see what that looks like in the calculator, there it is. All right, so once we know that, then we can use law of sines, and you can find angle A or angle B, it doesn't matter. I'll find angle A. So we'll do 11 over sine of A is equal to 13 over sine of 89.6. So we'll say A is inverse sine of 11 sine 89.6 over 13. So 57.8. And again, here you go in the calculator if you need it. All right, and then once you know two angles, you can find the other one. That's an 8, not a 6. I have no memory and I couldn't see it. You can find the other one by subtracting from 180. So we get 82.6. Alright, so if I was a betting person, I would bet that the next one's going to have two triangles because nothing has yet. Let's see if I'm right. Alright, so number 12. You have one angle and a matching pair. So you know you're going to really use law of sines, but you also know that it's ambiguous because you only have one angle with your matching pair. So we have to say that we know that the angle is less than 90, so that's case 1. Then we can compare side A to side B, and 9.5 is less than 22. So then we have to compare A to the height of the triangle, B sine A. So if I do 22 sine of 24, so B times the sine of A, I get 8.9. And side A is 9.5. That is greater, which means we have two triangles. All right, so we're going to have to figure out triangle 1 and triangle 2. So triangle 1. We know A is 9.5. We know B is 22. We do not know C. We know angle A is 24. We do not know angle B. We do not know angle C. Alright, so looking at what we have, we're going to find angle B first. So we're going to do 9.5 over sine of 24 is equal to 22 over sine of B. So we can get B by doing inverse sine of 22 sine 24 over 9.5. All right, so second sine 22 sine 24 divided by 9.5, we get 70.4. All right, so from there, we can subtract from 180 to find the other angle. I get 85.6. And then you're going to log sines again to find side C. So 9.5 over sine of 24 is equal to C over sine of 85.6. So C is whatever you get when you do 9.5 sine of 85.6 over sine of 24. Which is 23.30. All right, so that's triangle 1. Triangle 2. I'm going to come this way, I think. All right, so triangle 2. A is the same. B is the same. We'll find a new C, so call him C prime. Angle A is the same. We'll find a new B, B prime, and the new angle C, C prime. All right, so remember when you have two triangles, the first thing you're going to do is find your B prime. And B prime, like this angle. So if they gave you C instead of B, then you would just find angle C first here. Whichever one is the matching one that you would have used law of sines to find in the first place is the one that you find by subtracting from 180. So we can get B prime by doing 180 minus 70.4. And that's 109.6. And then we can find C prime by doing 180 minus that new B minus the A. I get 46.4. And then you can find C prime using the law of sines. So C prime is equal to 9.5 sine of 46.4 divided by sine of 24. And I get 16.9. Okay, so we are looking at area of a triangle now. So normally for the area of a triangle, you do base times height. Half of the base times the height. So like if this is my triangle, in order for me to find the area, I have to know this height and I have to know that base. Well, if I don't give you a base and a height, you have to have a formula to figure it out. All right, so if I gave you triangle ABC, remember we said that we could figure out H by saying the height of the triangle is equal to B sine A. We discussed that the other day. So if this height is B sine A, so normally that's the area of a triangle formula. So now we're saying that we want the base times the height, which we call B sine A. And then the base of our triangle may or may not be, hold on, because this is, I think, labeled backwards. This should be side B. This is the base of the triangle, but in our case it's C. So we'll go back to what I just said. So area of a triangle is 1/2 base times height. We know that H is equal to B times the sine of A, because we know that sine of A is H over B. Okay, so we replace the H with B sine A, and we replace the B from the area formula, the base, with our C. Then we have a formula for the area if I don't know the height of the triangle. So instead of having to stop and figure that out every time, we just have formulas to use. All right, so if I'm given side, angle, side, I have some simple little formulas that I can use to find the area. And it's just pick the one that has the letters that you know. All right, if I'm given the 3 sides of a triangle, we have Hero's formula. And I know that says Heron's, but it's pronounced Hero's formula. And S is the semi-perimeter. Sorry, my words left me. So add up all the sides, divide by 2. It's half the perimeter. So this formula uses the side lengths and the semi-perimeter. There's another set of formulas, but they're like a whole lot more like convoluted. And honestly, if they don't give you the information that you need for this, you're going to be able to find what you need for these formulas easier than having to learn other formulas. So we're just going to stick with these are the area formulas that we're going to use. So when you're doing the assignment, if you have information given to you where you can't use either one of these, then more than likely you're given 2 angles, which means you can easily find the third angle. And you can figure out a missing side using the law of sines, which will be faster than having to know a new formula. All right, so let's do a few examples. And all of these examples are straightforward. So again, on your homework, there's going to be a couple of problems where you're not given the right information. So you use the law of sines to find what you need and then use your formulas. All right, so here we have angle C, side A, and side B. So looking at your formulas, we have what we need for this guy. So we can simply say the area is 1/2 4 times 6 sine 120. And then it's just a matter of, can I type that in my calculator? 0.5 times 4 times 6 sine 120. And I get 10.4 square units. Because they didn't give us measurements for A and B. All right, so next, we'll keep these formulas where we can see them. Next we have the area of a triangular lot, 2 sides of lengths 90 and 52, and an included angle of 102. All right, so if you think about what this looks like, you have a triangular lot with sides of 90 and 52, and the included angle is 102. So obviously that's not drawn to scale, okay? But the point is that these 2 letters don't match that letter, if that makes any sense. So you can say that I'm telling you A is 102, and I'm telling you B is 90, and C is 52. I said B in low days. All right, so they gave you side, angle, side. You have the information. So to find the area, you can say 1/2 90 times 52 sine of 102. Parentheses are important. And I get 22 288.9. So 2,288.9 square units because it's area. All right, so these next two, let's see if you can see both of them at the same time, if that's a possibility. Yes. All right, pause and work these. Oh, we haven't worked examples of these. Sorry, I'm losing my mind. You could probably figure it out though if you want to pause it and try. All right, so let's look at number 3. So I give you 3 sides. So we're using this formula. So the first thing I have to do is figure out what S is. So 11 plus 16 plus 24. So remember that when you do this in the calculator, you have to figure out what that top number is and then divide by 2. You can put it in parentheses and do it all at one time. But if you try to type it in like this, the calculator is going to divide first and then add those 2 numbers to it, because that's what the order of operation says to do when you type it in like that. So either put the whole top in parentheses or figure out the top and then divide by 2 in a separate step. All right, so now that you know what S is, you're going to do the square root of S times S minus one of the sides times S minus another side times S minus the last side. Now, I don't need you to figure all of those out individually. We have a calculator. So just do second square root and type it in. Did I literally just write the letter B in the middle of my math problem? Mercy. That's a 16. So sorry. Alright, and then hit enter. And we get 66.3 square units. Alright, now you can pause and try number 4 since you've seen an example. Alright, so semi-perimeter. If we do 43 plus 53 plus 72, we get 168. Divide that by 2, and we get 84. So area is going to be 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. So typing all of that in the calculator, we get an area of 1,131.9. Okay, so since I'm not here to help you, I'm going to do one problem with you. So we'll add a number, not 4, because I know we're on that, number 5. We'll add a number 5. And let's say that I give you that A is 53, B is 70, and then I give you, we'll say side C is 15. Alright, so none of your formulas allow for 2 angles. So what you're going to have to do is figure out that missing side. I didn't give you a matching pair either. Hold on, let me look at your worksheet that you're going to get. It's not a good idea if I just make things up. Duh, I have a matching pair. I can just find the other angle. Sometimes I really do wonder about myself. Okay, so we can figure out the other angle to have a matching pair if we just subtract from 180. So we got 57. All right, so we now have a matching pair. We can do 15 over sine 57. I'm not solving the whole thing, so I'm not setting it up like I normally do. But I found the other angle, so I have a matching pair. And I just need to know one of these sides. It doesn't matter which. I'll figure out side A. All right, so side A is going to be pretty close to 15 because 53 and 57 are pretty close. 14.3. All right, so now I have the information that I need for this formula, this set of formulas. You can't see those formulas, can you? These formulas right here. I have enough information to do that. I have more than enough information, so I just have to figure out. But if you look, I have A and C. So that means we're going to use this one. So we're going to use side A, side C, and angle B. So we'll say 1/2 of 14.3 times 15, and then we'll do sine of 70. All right, so then we can, in our calculator, multiply that out and get 33.6. All right, if you have questions, please let me know.